So you can pick up what you have done, because I know Science is Weird has some fantastic courses. So pick up one that you're doing right now, and actually put out the framework of Egan, saying that this is the way you've improvised on it, and you have used some fundamentals out of Egan's philosophy.
Sure,
So
sure.
pick up one course and talk to us about it.
So I guess I'll use kind of riffing off of Newton here. Let me pick the solar system.
Hmm.
Is it okay if I'm going to science then? Because we've done some math courses too. We did one on the history of algebra
No,
last semester.
I think a solar system will be a great way to do it.
Okay. Okay. Um, so think about the way. I mean, here, how have you? What were you taught about the solar system when you were presented either in elementary school or later with the understandings that you got about the solar system? Like, what were you taught about it?
So it's a traditionalist approach.
Mhm.
How many planets are there? How is it? How are the planets revolving around the sun?
Mhm.
Okay, so how many of them are there? So it's like what you really said about the traditionalist education of saying, okay, dump
Mhm.
enough information into Swami, and there'll be some questions that are asked, and Swami should be able to answer that question. I was
Yes.
never, imagine if I were to, would it have excited me to become an astronomer? That's the question that I would ask you.
Yeah. Yeah. Yeah.
And I was not, right? I was said,
Yeah.
okay, here is an exam question, and I need to go out and, memorize it so that I can then write it and get my grades.
Yeah. Yeah. And what you were saying is so perfectly indicative of the traditionalist approach, where it sort of boils. It says the traditionalist approach says that learning is unnatural, or at least academic learning is unnatural. So what we need to do, and we're dumb. Students are. We should basically assume that students are dumber than you might otherwise assume, and so we should boil down the information to just be as simple as possible, and to give us the most important the most important concepts or pieces of data. And so the number of planets, the fact that they orbit the sun, the fact that the sun is in the center, right? That the Earth is not in the center. If you got a more advanced course, right, maybe you've been taught to learn the distances or even the relative distances between
True.
this sort of thing.
Correct.
Maybe you'd be
And how many moons are there for every planet?
sure,
And
sure,
things
yeah,
like that. So that's really what I would have
yeah,
learned.
yeah, yeah. Um, so an Egan approach, at least when I did our Egan approach, I as part of Science's weird sort of like mission, we are making this giant 6-year long comprehensive curriculum
Hmm.
that starting when kids are really quite young, about 8 years old, they can start to take that goes through, when they're then 14 years old or whatever. But it teaches them, like a college level, a real profound adult level understanding of things. Um, so we started off with the universe, our
Hmm.
very first course. Then we went to smaller things like water and lungs and snails and whatever. But we decided to start off with the big picture of life, the universe, and everything, or at least the universe and everything. Um, and one of the first lessons, I think the second one, was on exactly like, okay, so what is the solar system? And we started with this exact riddle that I asked students. Okay, what is the solar system?
Hmm.
And to a person, they said something pretty close to, well, it's a bunch of planets that are moving around the sun, that are orbiting the sun.
Hmm.
And what I showed them then, I told them that we wrote that sentence, and I said almost every word in that sentence is wrong.
Hmm.
That every one of these words has these bad understandings kind of baked into it. And the modern scientific understanding that we have of the solar system is incredibly different.
Hmm.
Such that, like, the word planet is a terrible word. It's a Greek word for a wanderer. And back in the day, the moon was considered a planet too because it wandered through the sky. The sun was considered a planet too because it wandered through the sky. They're
Hmm.
just these things, right? We used to imagine that the world was flat and that there was a dome of the sky and that all these things were moving across it faster than the stars were. That's why the stars aren't wanderers. And so, like, no, like, it's not that there's a sun and planets, right? Or at least there's not sun and wander. They all are wanderers through there. Okay, so that's probably not a very helpful thing to say with this. But it's also not true that the sun is in the center. Not exactly.
Hmm.
Because what Newton realizes, and we talked about the story of Newton a little bit, what Newton's breakthrough was it's not It's not just Galileo's universe where the sun is in the center and the other things are going around it. It's recognizing that all mass pulls on other mass, and the bigger something is, that the more massive something is, the more it will pull on things. So the sun orbits the planets a little bit. They're all orbiting each other. This is crucial because kids want to have, just naturally, right? We have this sort of essentialist understanding of the world where we want to imagine that like the sun like is in this one role and it does this thing. No, like the atoms that are in the sun are not special atoms. They are doing just the thing that atoms always do wherever they are. They're pulling on other things. And the sun is something that gets created out of that. I apologize. I cut you off a second ago.
No, that's okay. I think it's beautiful. I think the real question is you're going back and telling a story, the big picture. From the big picture, then you start to build the riddles and the metaphors, and then you actually go back and give examples. That's really how you are building the story, so that I get inspired by the story, and therefore I then start to get more curious. Right? I think
Yeah.
that's really the role of the teacher, is what you're talking.
I think yes. I think what's then missing in that take on it is that it's not just examples, because examples can be terrifyingly dull.
Okay.
It's that what Egan suggests that we do, and this is particularly true with science. This is actually less true with something like history.
Yeah.
In history, I think he invented his whole system based on history. So he actually, in some ways, has more to say about history than he does about science. But in history, it's a different thing. But in science, especially, it's about what are the students' assumptions. Let us flip that over. So then, by the end of that lesson, by the end of the lesson, you realize that, wait a second, like, even the word orbit is wrong. The word orbit means sphere, means ball. Once upon a time, we thought that the planets were moving on these literal glass crystalline balls around us all
Yeah.
of the time. We just couldn't see them. We saw through them to the stars behind them. And so like the word orbit has a misunderstanding baked into it. And you think, oh, who cares, right? I don't care about the etymology of the word. But we do when we understand that the old way that we saw the universe was that the Earth was in the center and that everything was going around the side of us. And then we switched that. We said the sun is in the center and the Earth is one of the things going around, but we never switched the perspective. But what Newton does for us is recognize that what the thing that is happening on Earth with the apple falling is the same thing that is keeping the thing that pulls the apple down is the same thing that holds the moon up. Which is to say that nothing at all is holding the moon up. Gravity means falling. Gravity was a word that he invented. Before him meant seriousness, right? Grave. But it just means that everything is falling. Everything is falling together and missing each other. And how can we, Egan would have us say, connect that in a really visceral way, somatic way to students. And the way is to recognize that, wait a second, we're using the wrong visual metaphor here. If we think about like the planets going on the side, I can talk to college students who understand that, okay, the planet's orbit and the equation for that is exactly, the gravitational orbit is exactly the same as the equation for, how far like a ball will be thrown if I throw it up in the air or whatever. But they do not understand that gravity by definition pulls things down. So that a more scientifically accurate way, according to Newton, to picture the universe, our solar system specifically, is to imagine that we are above the sun and we are always falling down toward the sun, and we are just happen to be missing. Lots of planets weren't so lucky. They just fell down to the sun and that's where they stayed. We're falling around the sun all the time. The amazing thing then about going to see, I took a vacation the last couple of weeks to go see the eclipse that came across North America. We managed to just barely see it. A cloud had covered almost the entirety North America, but the friend that we were with is a weather snob, and was able to read the meteorological charts, and with walkie-talkies talking between two different minivans. We were able to jet around the hinterlands, the boonies of Texas, in order to find a very small spot that the sky was visible for those crucial 5 or whatever minutes. But anyway, the amazing thing from that was not just looking up and seeing, oh look, it's really cool in the sky, right? My year-old daughter was able to appreciate that. She was pointing up to the sky, going, ah, wow, wow, right? And that is really cool. But then when you bring together this understanding of the solar system, where you realize, wait a second, in some important way, it's more scientifically accurate for me to say, not to say that I'm looking up at the sun in the eclipse, but I'm looking down at the sun. And the moon is 400 times closer than the sun. It's 400 times smaller than the sun. It's as if I'm at the top of a skyscraper and I'm looking down at the ground below. That's where the sun is. And I have a pea in my hand, and I'm stretching out the pea, and that is just about perfectly blocking this giant sun that is down at the bottom of that of the skyscraper. And the P is the moon right there, and like the Earth in this situation would be about the size of a tennis ball or something. That I'm looking from the tennis ball to see the moon, and it's blocking the sun, and then to recognize that in the eclipse you can not only see the stars. You can always see the stars at night. That's not particularly interesting. It actually is in some important ways if you know what stars you're looking for. But the amazing thing is that you could see Venus and you could see Jupiter. And I didn't think of this before I saw the eclipse. I thought about that afterwards. So I'm only doing this now in my memories. But you can see the entirety of the solar system with your own eyes. You can see Jupiter going around the sun. You can see Venus going around the sun. And if you actually then look at a 3D model and look at how far away these things actually are, oh my gosh, you can see everything. It is the closest thing that we have in predictable human experience to having a religious experience. I mean, I guess psychotropic drugs might be something similar, but this is something that it's like going to the Grand Canyon or some sort of natural feature where you're just overwhelmed, and you know you're going to be overwhelmed. A giant waterfall, by the size and immensity of it, except that this is literally tens of millions of times larger.